let me directly start with the example. So suppose the given decimal number is 63.543. So this given number is in decimal, so the base is 10. Now I want to convert this number into the hexadecimal. So this question mark represents I am supposed to find out the answer in hexadecimal number system. Okay. Now you can see this decimal number. There are two parts in this decimal number. First one is the integer part, and after decimal point this part is called as the fractional part. So we have to convert this decimal part also or integer part also in hexadecimal. Then we have to convert this fractional part also in hexadecimal. So there are two different methods used for that. To convert integer into the hexadecimal, we have to use the division method, in which we are going to divide this integer number by 16. Okay. And now again after that we have to convert this fractional part also into the hexadecimal, where we are supposed to use the multiplication method, in which we are going to multiply this fractional part with 16. Okay. So first of all, start with the process in which we are going to convert this integer part into the hexadecimal. Draw the structure like this. Write the integer number here. We want to convert it into hexadecimal, so divide by 16. Okay. So when we divide this 63 by 16, 16 into 3, 48. Okay. And 16 into 4 is 64. So here quotient we have to write as 3, and the remainder will be 15. Okay. So here we will write the 15. Is it right? No. Because yes, remainder is 15, this is right. But we cannot write the number 15 directly as it is in hexadecimal. What we have to do? In hexadecimal, there are capital letters used from capital A to capital F to represent the numbers from 10 to 15. So capital F is used to represent the 15. So instead of writing 1, 5, 15, here I have to write the capital F. Okay. Now next, here quotient is not 0. So again continue the process of dividing by 16. Divide by 16. Now you can see this quotient is 3. Okay. And this divisor is 16. This is smaller than 16, so we cannot divide. So write the quotient 0 and take this 3 as it is in the remainder column and collect these remainders from down to top to write the equivalent hexadecimal number. So how we can write? Write this 63. This is decimal number and its equivalent hexadecimal number will be 3f. So this is the hexadecimal equivalent of the given decimal number, but only integer part is considered here. Now what is left? We have to convert this fractional part also into the equivalent hexadecimal. For that we have to use the multiplication method. So pick only the fractional part. The fractional part is 0.543 multiplied by 16. The result will be 6.88. Now see the result. Here you can see the integer is 6 and the fractional part is 0.88. Okay. Now take this fractional part to the next line. 0.88 again multiplied by 16. The result will be 14.08. Okay. Now write this 14 here. Again the same thing. Can we write directly 14 in hexadecimal? No. Which letter we have to use? We have to use capital E. So instead of 14, here I will write the E and its value I will write in bracket, that is 14. Now again see the fractional part. Here also fractional part is not 0. Okay. So write the fractional part 0.08 to the next line, multiply with 16. The result will be 1.28. Here the integer part is 1. So write here 1. Okay. Now see, here again the fractional part is not 0. So there are 3 cases where we can stop the process of multiplication. One is if we get the fractional part as 0. Suppose in first iteration itself if you get the fractional part 0, then we will stop that process there itself. Okay. Now if we are not getting the fractional part 0, then the next is if the sequence of some fractional part numbers is going to repeat. That means if the loop is going to repeat again and again, we can stop the process of multiplication. And third one is, if first case is not there, if second case is also not there, then in third case we can stop the process of multiplication after taking 3, 4 or 5 iterations. So here I have taken the 3 iterations. Now here I can stop the process of multiplication. Now here the collected integer numbers are 6e1 and this is the multiplication process. So collect these integer numbers from top to bottom. So I will write the hexadecimal equivalent. First decimal number is 0.543. Here I have written h because h also represents the hexadecimal number system. For 0, hexadecimal equivalent is 0, and for 0.543 it is 6e1. 6e1 and the base is 16. Sorry, here not h. This is decimal number, na? So this is base should be 10, and its equivalent hexadecimal is 0.6e1. So I have written the hexadecimal equivalents separately of integer part and fractional part. Now I have to combine these two here. Okay. How to combine? Decimal 63. What is its equivalent hexadecimal? 3f. Point. Okay. 0.543. What is its equivalent hexadecimal? 6e1. 6e1. And this is hexadecimal equivalent. So this is very simple method in which we are going to use division method as well as multiplication method to convert the fractional part of the decimal into the hexadecimal. So to convert the integer into hexadecimal, we have to use the division method, and then fractional part into the hexadecimal, we have to use the multiplication method. Okay. So if you understand, please like the video, click on subscribe as well as click on the bell icon to get the notification of my next uploaded videos. And if you have any doubt, you can post a comment in comment box. Thank you.